Imagine a wall of fire, not a gentle campfire but a seething, invisible barrier hotter than the surface of our sun. This wall rages at 50,000 degrees Celsius. Now picture something built by humans hurtling toward it at over 50,000 kilometers per hour. Any collision should be catastrophic. Any encounter with that heat should mean instant vaporization. But this isn't science fiction. It's the real edge of our solar system. And something we built, Voyager, flew right through it and survived. Voyager, a tiny, tough explorer, traveled for decades past planets and storms, farther than anything made by human hands. Its destination, the vast ocean of interstellar space. But to get there, it had to cross this fiery boundary where the sun's influence ends and the galaxy begins. How did a 1970s machine survive a furnace that would turn rock into gas? The answer reveals a beautiful truth about the cosmos. Voyager's survival is a cosmic detective story, a tale of physics, engineering, and human audacity. The universe is often counterintuitive. What seems like certain destruction can be just another milestone. The heat was real, the speed was real, but our understanding of heat in the vacuum of space was the key. Voyager didn't just survive, it measured, studied, and sent data back across billions of kilometers. So let's travel back to the launch, ride along past the giants, and stand at the precipice of our solar system. We'll uncover the secrets that let our silent ambassador pass through the furnace unscathed. In the cosmos, things are rarely as they seem. Knowledge, not brute force, overcomes the most terrifying challenges. Voyager's journey through the fire is a story about us, and our ability to think our way through the impossible. Our story begins on a pale blue dot in the late 1970s. For the first time, humanity had the technology to send messengers beyond our planetary family. We built two Voyager 1 and Voyager 2. These weren't just machines, they were our eyes, ears, and hopes launched from Cape Canaveral in 1977. Their mission, a grand tour of the outer solar system, and then, if they survived, to keep going, forever. Packed with scientific instruments, they also carried a golden record, a message in a bottle for the cosmos. Greetings in 55 languages, music, and the brainwaves of a young woman in love. A hopeful gesture from a species just beginning its cosmic journey. Built with technology now ancient, their computers have less memory than a car key fob, yet they endure. Their resilience and ingenuity have outlasted generations, a testament to building for the future. These humble robots carry the spirit of human curiosity, slingshotting from planet to planet in a cosmic game of pool. Each new image and data point was a revelation, rewriting our understanding of the solar system. The Voyager's journey was just beginning. The first stops were the gas giants, Jupiter and Saturn. Voyager 1's images of Jupiter revealed the Great Red Spot as a swirling hurricane and discovered active volcanoes on Io. Saturn's rings, once thought solid, were shown to be thousands of ringlets shaped by tiny moons. Voyager 1's flyby of Titan revealed a thick, mysterious atmosphere, then sent it out of the planetary plane. Voyager 2 continued the grand tour, becoming the only spacecraft to visit Uranus, a turquoise world tipped on its side, with a corkscrewed magnetic field and new moons. Then in 1989, Voyager 2 reached Neptune, a deep blue world with the fastest winds in the solar system and geysers erupting from Triton. After these encounters, both Voyagers hurtled out of the solar system. Their planetary mission was over, but a new interstellar mission was about to begin. They had transformed our understanding of the outer planets, revealing a solar system more dynamic and beautiful than we'd ever imagined. The grand tour was complete, but the greatest journey was still ahead. Now, they would face the edge of the sun's domain. Beyond the planets, the Voyagers entered the heliosphere, a giant bubble blown by our sun. The solar wind, a stream of charged particles, inflates this bubble, which extends far beyond the outermost planets. But the heliosphere doesn't last forever. It pushes against the interstellar wind from ancient stars. Where these forces meet, a turbulent boundary forms. The first part is the termination shock, where the solar wind slows as it meets interstellar pressure. Voyager 1 crossed it in 2004, Voyager 2 in 2007. Beyond lies the heliosheath, a chaotic region where the solar wind piles up. At the very edge is the heliopause, the firewall. Here the solar wind's pressure fails and the interstellar wind takes over. This is the true edge of our solar system's influence, the cosmic shoreline. At this boundary, the plasma is superheated to 50,000 degrees Celsius. Logically, anything should be incinerated instantly. But Voyager flew through, its tiny transmitter still talking to us. The paradox was stunning. How does a spacecraft survive a 50,000-degree firewall? The answer: temperature isn't the same as heat. In the heliopause, particles move incredibly fast, so the temperature is high. But there are very few particles. Space is a near-perfect vacuum. Even though each particle is intensely hot, they rarely hit the spacecraft. It's like putting your hand in a hot oven. The air is hot, but not dense enough to burn you quickly. The heliopause is like that oven air, hot but too sparse to transfer much energy. Voyager didn't feel the heat, it flew through energetic particles, but the total energy was minuscule. The vacuum of space was its shield. The very emptiness that makes space cold and dangerous became Voyager's savior. Our earthbound intuition fails in the cosmos. The firewall was real, but its bite was toothless. Voyager's survival was a triumph of understanding, not just engineering. Voyager's survival was no accident, it was brilliant engineering. The team anticipated challenges no machine had faced before, especially temperature extremes. Voyager was wrapped in multi-layered insulation like a high-tech thermos to protect its electronics. Solar panels wouldn't work in the dark outer solar system, so Voyager used nuclear batteries, RTGs, powered by decaying plutonium. These simple, reliable generators have powered Voyager for over 4 decades. The vacuum of space, which shielded Voyager from the heliopause's heat, also preserves it. No air, no rust, no friction. Most components are solid state, protected by the emptiness. Voyager was designed to be autonomous. As it traveled farther, communication delays grew. Its computers were programmed to detect and fix problems, or wait for instructions from Earth. Robust insulation, steady power, the vacuum's protection, and smart software, these are Voyager's secrets. It was built to last, and it has. Decades later, it's still sending whispers from the edge. Voyager is a triumph of human foresight. After crossing the heliopause, Voyager became our first emissary to interstellar space. For the first time, we could directly measure the space between the stars. Voyager detected a surge in high-energy cosmic rays, atomic nuclei from distant supernovae. Inside the heliosphere, our sun shields us from most of these, but outside, Voyager measures the true galactic environment. Its instruments picked up a persistent low-frequency hum, the vibration of interstellar plasma. Sometimes, solar flares from our sun send shock waves that make the plasma ring like a bell. Voyager's data revealed the interstellar medium is dynamic and turbulent, not placid. Plasma density changes, and the galaxy's magnetic field interacts with our sun's in complex ways. With 2 Voyagers, we compared data from different locations, mapping the magnetic froth outside our solar bubble. They are no longer just planetary explorers, they are pioneers charting the galactic territory our sun will travel through for millennia. Every packet of data is a precious clue about our place in the galaxy. Voyager is our first and only direct link to the wider cosmos. The Voyager's journey can't last forever. Their nuclear batteries lose power each year, forcing engineers to shut down instruments one by one. Cameras are long off. There's only darkness now. Each shutdown is bittersweet, ending one kind of discovery but extending the mission's life. The goal: keep at least one instrument running until around 2025. Eventually, there won't be enough power to send even a carrier signal. Around 2036, the Voyagers will fall silent. The Deep Space Network will hear only cosmic static. But their journey won't end. They'll coast through the Milky Way, silent ambassadors carrying their golden records. They are, for all practical purposes, immortal. Their legacy is secure. They reshaped our view of the solar system and gave us our first taste of the galaxy beyond. The end of their communication will be a long goodbye to old friends, but it will also be a triumph, a mission that achieved more than anyone dreamed. Voyager's story is a human story, a species that looked up and had to see for itself. We packed our curiosity, music, and greetings onto 2 small ships and cast them into the cosmic ocean. They have traveled farther and longer than anything we've made, outlasting their creators' expectations. They remind us what we can achieve when we work together and dare to explore. Surviving a 50,000-degree firewall, exploring alien worlds, communicating across billions of kilometers, Voyager shows the impossible is possible. The Voyagers opened the door to interstellar space. It's up to us to walk through it. Future missions will follow, building on Voyager's discoveries and mapping the galaxy in greater detail. The journey of exploration continues, from our ancestors to these robotic pioneers. So next time you look at the night sky, think of Voyager, our legacy, coasting silently through the stars. Their journey continues, and through them, so does ours.